Hey there, science fans! Today we're diving into the fascinating world of separation techniques. Specifically, we'll be exploring two methods that are essential in countless industries and even in our daily lives: filtration and centrifugation. Ever made coffee with a filter, or seen a washing machine spin out the water from your clothes? These are prime examples of filtration and centrifugation at work. These techniques help us separate mixtures based on the properties of their components. Whether it's removing impurities from water, isolating cells for medical research, or even making delicious fruit juice, filtration and centrifugation play crucial roles in our world. So buckle up, because we're about to embark on a journey to uncover the science behind these amazing separation techniques. Filtration is like using a tiny net to separate things based on their size. Imagine you have a bowl of sand mixed with water. You can't just scoop out the sand with your hands, right? That's where a filter comes in. A filter is a material with tiny holes or pores that allow liquids or gases to pass through, while trapping larger solid particles. Think of it like a sieve or a strainer in your kitchen. When you pour the sand and water mixture through the filter, the water easily passes through the small holes, leaving the sand behind. Filtration is essential in many aspects of our lives. It's used to purify our drinking water, clean the air we breathe, and even filter out harmful bacteria from medications. Without filtration, our world would be a much dirtier and less healthy place. Now, let's take a closer look at how filters actually work. It's not just about the size of the holes. There are several mechanisms at play that help trap those unwanted particles. Filters are more sophisticated than they might appear at first glance. 1. Size exclusion. This is the most straightforward mechanism where particles larger than the filter's pores are simply blocked. It's like trying to fit a basketball through a soccer net. It's not going to happen. This method is highly effective for larger contaminants. 2. Interception. Sometimes particles smaller than the pores can still get trapped if they follow a path that brings them into contact with the filter material. Imagine a small leaf floating down a stream and getting caught on a rock. This mechanism is crucial for capturing medium-sized particles. 3. Inertial impaction. When a fluid carrying particles changes direction suddenly, the particle's inertia can cause them to collide with the filter and get stuck. Think of dust particles hitting your car's windshield when you slam on the brakes. This is particularly useful in high-velocity environments. 4. Diffusion. Very small particles like smoke particles move randomly in a fluid. This random motion can cause them to collide with the filter fibers and get trapped. It's like trying to find your way out of a maze. Eventually, you're bound to bump into a wall. This mechanism is essential for capturing the tiniest particles. 5. Electrostatic attraction. Some filters have an electrical charge that attracts and holds onto particles with an opposite charge. This is like rubbing a balloon on your hair and then using it to pick up small pieces of paper. This method is particularly effective for fine particles and adds an extra layer of filtration. These mechanisms often work together to ensure efficient filtration. Pretty cool, huh? By combining these different methods, filters can capture a wide range of particle sizes and types, making them incredibly versatile and effective in various applications. Filters come in all shapes and sizes, from simple coffee filters to complex industrial filtration systems. Let's explore some of the main types and their unique applications. 1. Gravity filters. These are the simplest type, relying solely on gravity to pull the liquid through the filter. Think of a basic coffee filter or a water filter pitcher. These are commonly found in households and are easy to use. 2. Vacuum filters. These filters use a vacuum pump to create a pressure difference, sucking the liquid through the filter faster. They are commonly used in laboratories to separate solids from liquids quickly. This method is efficient and widely used in scientific research. 3. Pressure filters. These filters use pressure to force the liquid through the filter, making them ideal for handling large volumes of fluids. They are often used in industrial settings for water treatment or oil refining. These systems are crucial for maintaining the efficiency and safety of large-scale operations. The type of filter used depends on the specific application and the properties of the mixture being separated. No matter the type, filters play a vital role in keeping our world clean and safe. They ensure that we have access to clean water, purified air, and safe products. Section 5. Spinning things around. An introduction to centrifugation. Now let's shift gears and talk about centrifugation. Imagine swinging a bucket of water in a circle. The water stays inside the bucket even when it's upside down. That's because of centrifugal force. And it's the driving force behind centrifugation. Centrifugation is a technique that uses centrifugal force to separate components of a mixture based on their density. It's like a super-fast merry-go-round for separating different substances. Centrifuges, the machines used for this process, come in various shapes and sizes. They all work by spinning samples at high speeds, creating a centrifugal force that pulls denser components away from the center. This technique is widely used in various fields, from separating blood components in medical labs to clarifying fruit juices in the food industry. It's a powerful tool that allows us to isolate and study specific components of mixtures with incredible precision. Section 6. Centrifugal force, putting a spin on gravity. Let's delve a bit deeper into the fascinating science behind centrifugation, a process that harnesses the power of centrifugal force. You know how gravity pulls everything towards the center of the Earth? It's a force we experience every day. Well, centrifugal force acts in the opposite direction, pushing things outward when they're spinning rapidly. Imagine you're on that merry-go-round again, spinning faster and faster. As it spins faster, you feel a force pushing you outward, right? That's the centrifugal force in action. The faster the spin, the stronger the force becomes, making it more pronounced. In a centrifuge, the spinning motion creates a strong centrifugal force that acts on the components of a mixture, separating them. Denser components, being heavier, experience a greater outward force and move further away from the center of the centrifuge. Lighter components, on the other hand, stay closer to the center, experiencing less force. This difference in outward movement allows us to effectively separate the components based on their densities and properties. It's like sorting marbles by size. The larger, heavier marbles will roll further away when you tilt the tray, while the smaller ones stay closer. Section 7. Different spins on separation types of centrifuges. Just like filters, centrifuges come in different types, each designed for specific applications. First, we have batch centrifuges. These are the most common type and work with fixed volumes of mixtures. You load the sample, spin it for a set time, and then stop the machine to collect the separated components. Think of it like washing a load of laundry. You put the clothes in, the machine runs its cycle, and then you take out the clean clothes. Next, we have continuous flow centrifuges. These are used for separating large volumes of mixtures continuously. The sample is fed into the spinning rotor, and the separated components are continuously removed. It's like a conveyor belt of separation. The type of centrifuge used depends on factors like the volume of the mixture, the desired separation efficiency, and the properties of the components being separated. Section 8. Filtration and centrifugation in action, from water to medicine to food. Now that we understand the basics, let's see how filtration and centrifugation are used in the real world. Water treatment is one key area. Filtration is crucial for providing us with clean drinking water. Water treatment plants use a combination of filters to remove sediment, dirt, bacteria, and other impurities from raw water sources. In pharmaceuticals, centrifugation plays a vital role in drug development and production. It's used to separate cells, purify proteins, and isolate specific components of medications. And in food processing, both filtration and centrifugation are essential. Filtration clarifies fruit juices and removes impurities from syrups, while centrifugation separates cream from milk and extracts oils from seeds. These are just a few examples of the countless applications of filtration and centrifugation. These techniques are essential for maintaining our health, producing vital products, and even making our favorite foods and drinks. Section 9. Wrapping it up. The importance of separation techniques. Filtration and centrifugation are essential tools for separating mixtures and isolating specific components. These techniques rely on different principles. Filtration uses size, exclusion, and other mechanisms, while centrifugation harnesses centrifugal force. From purifying our water to developing life-saving medications to producing our food, these separation techniques play critical roles in countless industries and impact our lives in numerous ways. Understanding how these techniques work and their diverse applications gives us a greater appreciation for the science behind everyday products and processes. Section 10. Keep the curiosity going. That's all for today's deep dive into filtration and centrifugation. I hope you learned something new and exciting about these amazing separation techniques. Remember, science is all around us, and there's always more to explore and discover. So keep asking questions, keep experimenting, and keep that curiosity alive.